Hello, good day everyone. Today we are planning to mainly discuss on the path to software engineering leadership. These are probably evolutionary thoughts that after having spent some time with software architecture and design of systems, we have observed how we could get to leadership positions by being a good follower. Hope you will enjoy this. So when we discuss about software systems, they have evolved over a certain period of time with several changes, including agile and moving to a continuous engineering phase. Many of us would have gone through this phase of being at the crossroads, trying to overcome the challenges to move to leadership roles, whether it's a technical lead, technology lead, or kind of architecture, whether it's also a managerial role which requires architecture and design knowledge or software engineering knowledge to a lot of detail. So here we are discussing this kind of a transition and some major milestones. What I have done here is this video which will share a kind of a glimpse of how we can improve ourselves and become a better leader by just being a follower. And then I have also shared some of the write up in the form of a handout, which will also be shared as part of the attachment. Thank you. So, we have been hearing this software is eating the world ever since Mark Anderson mentioned it in Wall Street Journal in 2011. And obviously, we are overwhelmed by the kind of devices and equipment coming around us, and many of these devices and equipment, in whether it's a washing machine, whether it's a smart TV, whether it's mobile device with the applications, whether it's a Google search engine, whether it's an escalator, or even a space travel. Uh, Software is probably everywhere in our systems, and they kind of um, are more invisible and kind of even if you look at Ingenuity Mars helicopter, uh, the interesting fact is one of the main processors is a Qualcomm Snapdragon processor, and it runs a Linux operating system within it, which is kind of a cousin to the other commercially available capabilities. So what we can look at is software is there around us everywhere. And when we listen to Jan Bosch, a professor at Commerce University, and also the uh, vice president, so he held several positions like vice president at Intuit and with Nokia. He talks about why is this software such a valuable technology today. This is important to understand because it allows us to have more fine-grained, customized, personalized behavior. So in today's world, when the products are kind of changing our own behaviors, this plays a very important role. And it is infinitely more malleable and changeable than more traditional technologies. So it is probably much more easier to change or changeable than the traditional stuff. And then software like hardware equipment, for instance, there are you need to make major changes to it, and there are physical changes associated which is not there with software. And software allows for order of magnitude shorter feedback loops, which is another major area of work where it allows us to um, connect with our customers and have the customer feedback, which enables us to stay lean and build better systems. So this kind of sums up the significant role played by software and why it is kind of eating the world. This perspective is important for us to understand the significance of why software engineering is a major player within every systems engineering or engineering segment of all the kind of uh, systems around the world. So how did it evolve? Was it how did it kind of emerge from its different phases of maturity? Is kind of described by Ewan Woods in his famous talk in the Saturn event, and also described in his publication, which talks about the evolution. He talks about it in various phases. 1980 towards from a monolith, it started moving to kind of distributed monoliths. So the kind of it became starting to get more modularized. Then it started to get internet connected. So the internet came into the picture, and then internet and system around the internet slowly collecting up. And then we now what we are seeing is the intelligent connected kind of architecture paradigms. So when we look back at this evolution, yeah, let us look at smart buildings. So we are discussing about smarter grids and smarter cities. Most of this looks intelligent and connected. And this is interesting that it is already there in and around us in much more visible forms of work. And how does these paradigms and the evolution as we go, how does this change the kind of software architecture which is considered software architecture and design, which is considered an important element of how software should evolve? So Ian goes about talking about it is going to be increasingly around data and algorithm design compared to the structural angle of it, and emergent runtime structure, which is means to say more in the evolutionary direction, how things will compose together. Decisions are more replaced by principles, policies, and algorithms which can evolve faster, and more to in the direction of probability, which machine learning and data science and kind of aspects also coming into the picture. Operational policy and automation. So here is one more area of work where we see industrialization, particularly with software. Industrialization is more about the manufacturing kind of element, which is more in the direction of deployment. And we are seeing the expenditure angle moving from capital expenditures to operational expenditures, because when the cloud comes in or the distributed systems comes in, we are talking about different other financial or budgetary concerns, consider more moving from the capital instead of continuous operations driving the business. So one of the when we look at this evolution again, one more major look at how this evolution has kind of shaped up is to hear Martin Fowler, one of the main shapers of architecture thought process in the software industry. So when we listen to him, particularly his article in IEEE software, where he discusses in length and breadth with one of the major proponents of object-oriented design, Ralph Johnson. He discusses about software is not limited by physics like the buildings are. It is limited by imagination, by the design, by organization. And this is where I think it is more important for us to focus on the design aspects. And in short, it is limited by properties of people, not by properties of the world. So when we look at this statement, it is a profound statement when we look at it. On one side, software kind of clubs the best of man and the machine, because humans are capable of imagination, creativity, and teams. And on the other side, it's also about kind of structuring things in a fashion which is more executable. So the organization, the design aspect of it, how it is modular and plays a very big role. And then in this discussion with Ralph Johnson points out that one of the key differences between building architecture and software architecture. While decisions about a building are hard to change, like the foundations, for instance, it's not easy to change. In the case of software, it is something that we have to understand that it is possible to change. And particularly, this is very evident when we started doing migrations with databases. So we could find that we could refactor databases, we could refactor services, we could refactor almost everything. So this kind of set the stage for um, the evolution to means to say that yeah, we can change more often and how to do this better. On this is one view of it. On the other side, we have um, software reliability angle from Dr. John Musa, who talks about the software. The bathtub curve for software is something that we really need to look at, because software by itself doesn't reach an obsolescence, unlike a hardware element which can wear out after a period and then it fails. Software itself is more affected by changes, and every change, every upgrade can lead to some influx in terms of problems, findings of defects, and then we have to stabilize it further. But if we are able to continuously churn out and handle these changes in a more organized fashion, software can live longer. So that is also the kind of thinking that says to us in this evolution, and that these thought processes kind of set the value of software higher. At the same time, instead of just staying like static, the objective is more to be evolutionary and more in the direction of change, organize for change. So when we were going through all this kind of evolution on the human side of things, Agile came into the picture, where we finally kind of started to realize that humans are the ones who create this software and the teams are the ones who deliver. And if you really have to do a great job with software and many other similar kind of systems, we have to also kind of organize our teams and kind of into like commando groups which can act more independently, take decisions. So on the right hand side, when you look at it, does it mean speed? Not necessarily, because when we look at cheetah, the fastest animal on the planet, it can accelerate from 0 to 60 millimeter per hour in 3 seconds. But the strength of cheetah is not in its speed, it is in its ability to leap sideways, changing directions, slowing down quickly, kind of. So, no, it is also known that no sprint runner can continuously run fast. Instead, they can only attain high speeds in short bursts. This is kind of an realization for us as human beings also. The idea of an agile business is more about consistency and able to change directions, slowing down, leaping sideways, which is more possible with a dynamic team around. So this, while this stage got set, on the other side, we were kind of still trying to see how we could design while in this continuous flux of change which Agile introduces. So that is where Eljo came with this approach of risk and cost driven architecture, where you kind of balance the cost and risk, which is also kind of a language which is known by project managers. And then we drive in the direction of risk and cost and communicate risk and cost accordingly, create roadmaps which provide us um, capability to balance the architectural elements as well as the features. So again, in states, another recent developments, architects acting less upfront structure designers and more as overseers of a stream of informed significant decisions just in time. This is important because when you have a more autonomous team, you need to have more spread out decision making, which is very important for everybody to feel that ownership and pride of creating the software. And architecture, it is also often to be understood that this is kind of directing us to the direction of what Simon Brown talks about, like an architecture design, like a map of software. So it kind of provides us the directions, but instead you still have enough tires where you can still take a little bit deviation from the track, but the point is your objective should still be met, kind of parlance. So what we see is architecture and design of software is kind of turning into a guidance system which allows us to be more agile, which means able to change directions, slowing down, leaping sideways, balancing our risk and cost, giving the right positioning in terms of architecture and features. So this kind of evolutions finally are taking us to a picture which is seen as continuous software engineering. So when we talk about continuous software engineering, the work that Rebecca Parsons, the CTO of ThoughtWorks, has done in evolutionary architectures in her famous book, um, where she discusses how the evolutionary architectures are coming into the picture and how fitness functions, which is nothing but kind of ways to handle technical debt without and guidelines for evolution, together with the test strategy and kind of continuous integration approaches, gives us a guidance path for evolving. So this being said, um, it is important for us to notice that the unicorn project, that Jane Kim has presented in his famous book, for kind of discusses this in the form of a novel, the five ideals, which is about locality and simplicity, focus, flow and joy, the improvement of daily work, psychological safety, and customer focus. When we are moving into continuous software engineering, we are talking about life in a treadmill. So the importance is more like we are in a continuous movement. So unless we have the infrastructure to support, which means to say continuously evolve and kind of redefine ourselves and stay ahead without being affected by friction, which is nothing but the technical debt which can pull us back. This is an important dynamics which we need to understand and continuously look at. And so when we are talking about cloud native, the concepts around continuous delivery, containers, microservices, DevOps, all these kind of brings into the picture a continuous mode of evolution of the systems driven by the distributed systems directions as well. In his famous book, Software Driven World, Speed Data and Ecosystems, Jan Bosch talks about the three pillars of transformation, which is driven around speed, data, and ecosystems. When he summarizes that kind of R&D cycle trumps all the kind of mechanisms for speed, that is something important for us. And data playing a very important role as we go forward, and the ecosystems which involve the internal organization systems, open source, the supply chains involved in software, as well as everything else, plays a very big role in this transformation journey. While we see all this in picture, it's important for us to, when we are looking at evolutionary architecture and continuous systems, we have to see the balance between human and machine as an important element of the game. So when we are talking about human, it's about the teams, it's about leadership, and when we are talking about, it's about the industrialization element of software, which is also to do with more integration, automated tests, dashboards, the continuous delivery angles, DevOps aspects, while the human, who's mainly playing the role in terms of innovation, architecture, and design and exploration. Kind of balancing these two is very important as we go forward. So, what we have done is kind of summarize some of these milestones, what we have noticed in the path to leadership in software engineering, more focusing on software architecture to a certain good extent. And then we have here the references and an article handout, which uh, discusses in detail how it can be done. So, thank you very much for your kind attention. Have a nice